All right, so I had some comments about stuff that a lot of people missed. Not the 50% threshold, which makes me go back and give everybody the points, but a lot of people had questions over these. So if you're looking at your feedback on your exam and you see something that says go and see the notice, well, here it is. So the first question that people had any comments on, my question was, and I should have highlighted the erroneous part or the confusing part, there's more than one way to do this, but it shouldn't take more than 4 lines of code. Do it in 1 to 4 lines of code. Yeah, you couldn't do it in 1 line of code unless you just appended a whole bunch of stuff. You could if you just had a constructor, but we don't have a constructor. So how in the world did I think you could do this in fewer lines of code than 4? I don't know. It takes 4. All right, it's really annoying that this is wider than... Thanks, guys. I guess I should just post this as a document because half the text is scrolled off the side.
I guess it's a red day today.
I'm going to leave that. Yeah, you can go and read the notice. I'll revise it and upload it as a Word document to make it easier to see. Alrighty. So what did we do last time? We have done some stuff on Chapter 10 and Chapter 13. And we may be almost done talking about inheritance as its own thing. And now we need to go in and talk about polymorphism and creating interfaces. So let's go check our PowerPoint. Well, this is indicating we're not very far into it. Okay, so when you need to call your parent's class's constructor, your superclass's constructor, you just use the super keyword, and then if it's a parameterized constructor, you pass some arguments in like that. And I think we did that in one of our last examples. So the constructor call is only allowed if it's the very first line in the constructor's body. So the way that looks is something like this. Class, parent, whatever, and I'm going to make a constructor for him. Public, parent, and he's going to take a string for some reason as his constructor, as his parameter. And I guess when he's called, I'm going to just print it out. System.out.println, parent, constructed. This is not valid code, obviously. Constructed with, and then plus s, right? Okay, so now when we want to inherit from parent, class child, it extends parent. We're going to give him his own constructor, and for some reason we feel like making him have a different style of parameter, or maybe nothing at all. Public child and he's going to call the superconstructor or the superclass's constructor and pass in some parameter. I am a child, like that. And then down here, when we create a parent, we would have to create it like this. Parent P is equal to new parent. The parent constructor has to accept a string. So maybe his name is Dad, Mom, something like that. But if we create the child, his constructor doesn't take any parameters. But on its way towards being constructed, it calls the parent's constructor and passes that in, passes that parameter in. So I hope that's clear. Why do you need to do that? Well, if you have a parameterized parent constructor, and then you're inheriting from that class, you're extending from that class, you have to have some way to pass those parameters into that parent class's constructor. And if you have a class that inherits from a class that inherits from a class, you might have a chain, of these super And you make a grandchild class, right? Class grandchild extends child. And he is going to call his base class public grandchild. The syntax for this is different in C++, by the way, just for those of y'all who've done both. Alrighty. And then you're just going to call super, but with no parameters, because the child class doesn't take any arguments. So when you created a grandchild, it would invoke the grandchild's constructor, which you call super to jump it up to run the child class's constructor, which we call super to run the parent class's constructor. What happens if you have a super constructor call and then a this constructor call is the first two lines of the constructor?
It failed.
Did you just try it?
I ran this code as during the test and it failed, and that is why.
So you actually typed in what I was typing in and it failed on
The
you?
monster, you didn't ever declare M2, so it was,
Oh, is this on the monster class?
yeah. So it never printed Bob, like it would not get through its.
I thought we had that right. All right. Based on a question, I'm going to go back in and see if I can find my monster project.
It's.
Wow, all of a sudden there's an annoying hum. Okay.
Oh, wait, go back. You don't have a monster class?
Yes, I do.
Do you? We have a monster class?
I made a monster class.
Oh, okay.
Oh, you made a class. All right. Let me pause this and go look.
Just string me.
So that was actually regarding a test question. Let's go back and look at that specific test question if we can view it, zoom in on it. Maybe if I edit the notice, we can see it. This is the one regarding Sam and Bob.
Well, all in all, I didn't do like that.
So we had a class named Monster, and we had a public class named Java Application 37. Now, if you actually took the time to try to type all this in, it would have to go into a file, a file named Java Application 37.java. And you could stick this monster class above it because it doesn't have the public keyword, and it is legal to stick, or you could just make a monster.java class yourself. So if you tried to type this in exactly, but you stored it in a monster.java, I didn't really want you to actually type it all in during the exam. I just wanted you to eyeball it. So we have a monster class. He's got one member. Then down here, oh, maybe people also didn't think it was going to compile because it doesn't have the public keyword there. So here we create one monster, and then we create another reference to it. Monster M2 is equal to M1. That just copies the address that's stored in M1 into M2, so they are now the same object. So we change the name of that object to Sam, and then we turn around and change the name of that object to Bob. Just like you have two signs pointing to the same house, if you walk to that house via the second sign, it's still the same house. So M2.name, that's the final state of the name variable, the name member. So when we print it out, it prints out Bob. And for the folks who said it just wouldn't compile, I should take that option off because I didn't. There's no syntax errors in it, but you have to put them in the right .java files. Alrighty, so let's go back here to our.
Actually, get on
See,
Sorry.
this. So let's play with these constructors a little bit more. Go ahead and make a Java application. New Java project. I'm in Microsoft Visual Studio. That's not going to do us a lot of good. Let's actually do NetBeans. New project. Next. Finish. All right, so if you add a constructor, and I'm going to do that horrible thing where I create a class inside of a class. Okay, so I'm going to create a class called monster. And it's going to have two constructors. So public monster, which accepts a string S, and it prints that string that's passed to it. System.out.println constructing and then plus S. So constructing space, end quote, plus S, into parentheses, semicolon. Now that's one constructor. It's a parameterized one, so we can construct a monster named King Kong and another one called Oscar the Grouch. Now let's do one that is a default monster. So public monster with nothing between the parentheses. And we're going to call the other constructor. Now we don't have any names, so I'm just going to call him default. It's our default monster, right? So when this object is invoked, if we don't pass in any arguments, this is the constructor that's going to run. This keyword goes and executes this constructor. So down in main, see if I can fit this all on one screen, which is always futile. Alrighty, I'm going to create two monsters. Monster M1 is equal to monster, no parameters. Monster M2 is equal to monster, passing in King Kong. And it's complaining. Cannot find symbol, method monster. New monster. Monster M1 is equal to new monster. Monster M2 is equal to new monster. All right. So when I run it, well, I built it, didn't run it yet. He's not doing a thing. System.out.println, done making monsters. And I'm putting this all outside of main. That's the problem. Alrighty, cut those 3 lines, go in and put them inside of main, then it'll work. Alrighty, so it constructed our default monster there. It constructed King Kong there. So when we did our default monster, it ran up, it did this constructor, which called this constructor, passing in a default argument as our to fill in our parameter. Hope that's clear. Now the question that the PowerPoint is asking is what happens if you have a superconstructor call and then a this constructor call as the first 2 lines in a constructor? Let's find out. Here I'm just going to call objects constructor. Everything is inherited from objects, so I can just do that. Or not. Recursive constructor invocation. Excuse me, not this, super. That will call the object classes constructor. And it says that the call to this must be the first statement in the constructor. So let's remove that one, and we're going to call this, and now we're getting another complaint that the call to super must be the first statement in the constructor. So essentially, in my mind, it's a trick question. Your call to another constructor has to be the top line of code in that constructor, regardless of whether you're calling your parent's constructor with the super or whether you're calling your own alternate constructor like that. So, seems like a trick question to me. As you may recall, in an instance method, if you call a method that's in the same class, you use the reference variable dot prefix is unnecessary. In other words, you don't have to type this dot. Likewise, in an instance method, if you're calling a method that's in the parent class, in a superclass, you also don't need this dot. So we've talked about the superclass constructor, calling it with the super keyword a couple of times. Method overriding. Method overriding is when a subclass has a method with the same name and the same parameter types as a method in its superclass. If a subclass contains an overriding method. All right, let's do that. Let's add on to our monster class a method called speak. So public void speak. And if it's a default monster, all it does is go roar. So system.out.println roar. But now let's inherit from our monster class. I'm going to come down here and make a new monster called Godzilla. Class Godzilla. I shouldn't do this. This is going to be Oscar the Grouch. So class Grouch. I don't know how. The only reason I'm doing that is because I don't know how to write the sound that Godzilla makes. So anyways, class Grouch, open brace, but before the brace, he extends the monster class. He needs to call the monster class's constructor. So let's give him a constructor. Public Grouch. We're not going to let, I guess we could take a name. Nah, good enough. And then inside here, we're going to call the super constructor, and we're going to specify that his name is Oscar the Grouch. Now let's override the speak method. So I'm going to leave off the @ override for now. Public void speak. And what does Oscar say? System.out.println. I love it because it's trash. And the comment, the warning over here is asking that we want to do no, I don't see what's going on. Except I've just inserted a breakpoint. All right, so there it is. It says overrides method. So I'm going to go above it and do the @ capital O override syntax. See if that gets rid of our error. I think it does. I think it says Control-Shift-P goes to the ancestor method. So Control-Shift-P, if you're using NetBeans, takes us to this method right there, the speak. So we have two speak methods, one in the parent class, monster, which says roar, and one in the child class, the subclass, which says I love it because it's trash. Now we've already made a monster named King Kong. Let's make one more monster. So underneath monster M2, monster M3 is equal to new Grouch. And for you guys who didn't grow up with Sesame Street, this might not make so much sense. All right, so M2 is going to speak. Monster's not spelled correctly. M2.speak. M3.speak. Here we go. Constructing default monster, King Kong, constructing Oscar the Grouch. We call King Kong's speak method. He said roar. We call Oscar's speak method, and it says I love it because it's trash. So I've been having us use override before this point to implement toString and dot equals. So the concept ought to be already familiar. Now we have it officially right, and it could appear on an exam. I don't think that I asked you to write a toString method or an equals method in your last exam. Seems like we needed to, though, in an earlier chapter. Anyways, so if the subclass and the superclass have methods and the same parameter types and different return types, it generates a compilation error. Just like overloading. If you write two identical method headers, but one of them has a different return type, it wouldn't know which one to call. For example, if for some insane reason I wanted speak to return something, and so I wrote another one, public int speak, or public string speak. I'm just going to make this one say return 0. That's a syntax error because when you invoked speak, it wouldn't know whether to run that one or that one.
But if it takes parameters, can't you write a method that takes...
Right. If you pass in different parameter lists, then they could return different values. They could have different return types. So if this one takes an integer, then sure, make it return an int. And then if this one takes a string or nothing, sure, have it return a void. That's not a syntax error. It's only if you have two identically declared methods with different return types. Does that make sense? Okay. I'm going to skip their examples because you can read their examples. Final. If you want to specify a method that cannot be overridden in a subclass, you can use the final modifier. Now, we've already seen final before in a different context, which is to indicate that an int or a string or something was immutable, that it could not be modified. This seems like a slightly different use of it. But if we went up here to the monster class and we made speak a final method, then when we try to override it down in Grouch, that's an error. Cannot override a final method. So if for some reason you have some methods and you don't want another programmer to come in and modify their behavior after they inherit your class, that's how you do it. I'm going to go and remove that because it caused a syntax error for us. So now it just says public void speak again. Why would you ever want to use final if you think that your method is perfect? You might want to use final to prevent anyone else from overriding in the future. Final methods might run faster since the compiler can generate more efficient bytecode. There's no need to run up the chain in order to figure out which method to invoke. Aggregation, composition, and inheritance compared. We've talked about two types of class relationships. Aggregation and composition are when one class is whole and the other classes are parts of it. You have a book class and then you have a library full of books. You have an employee class. What did we do? We did a car dealership class and it had, a list of cars and it had a manager. So it was using composition so that the dealership class contained as instance members references to other classes. An inheritance relationship is when one class is a more detailed version of another class. The subclass is a more detailed version of the superclass. So our Oscar is more detailed than the monster class. Now in this case we weren't taking the time to flesh it out, so is it really more detailed? No. But we would add additional members and additional methods to our Oscar class that the monster class didn't have. The more detailed class is the subclass, the other class is the superclass. The subclass inherits the superclass's members, the variables and the methods. Now if you mark those members and methods as private, then the subclass doesn't have access to them. If you want access to those members, by the way, you use the the protected keyword. I could go into my code here and decide that a monster does have a name, but instead of making it private, I'm going to make it protected string name. Then down here inside the Grouch class, I would be able to do something with it, like name is equal to, Oscar, whatever. So here I am able to access the variable that's in the superclass. But if I made it private, I would not be able to. I'd have to invoke getters and setters just like any client code. I'm getting a red arrow over here, so if I scroll down here and I see where I reference name is equal to Oscar, it didn't work. So I'm going to go back and make that protected. So class monster now has a protected string name. I'm just going to delete that entirely. Just remember that's the case. Private means only that class and not even your child classes, your subclasses can get a hold of that method or that variable. Protected means that your child classes, your subclasses can't. All right, I've removed all references to the name member. So aggregation and composition are has-a relationships. One dealership has a bunch of cars. One dealership has a manager. So you have a container class and then you have component classes inside it. And if you remember, the difference between composition and aggregation is that aggregation is when you can share things between two classes. Like you have two bookstores and they're sharing the same books for some reason. You'd use aggregation for your book list. But your car dealerships are very greedy. They don't allow them sharing cars between car lots. Then they would use composition. Each one would have objects that were owned only by that dealer. We call inheritance an is-a. Oscar is a monster. Charmander is a fire-type Pokemon who is a Pokemon. You know, a Lamborghini is a car, but a car has wheels and an engine. So the wheels and the engines would be done with aggregation and composition. Probably composition because each one has its own engine, right? You're not sharing your engines between two cars. Aggregation, composition, and inheritance combined. Here's an example of aggregation and composition. You have a dealership. He's got one car, well, multiple cars, and then you have a manager, and then you have a salesperson. So remember that a solid diamond indicates composition, hollow diamond indicates aggregation. A manager could manage more than one dealership, so this manager may be shared between several dealership objects. A salesperson could work at more than one dealership. He's got a nighttime job where he's working, for the Chevy dealer as well as the Ford dealer. Bad salesperson. But the cars are limited to only that specific dealership, so it's composition rather than aggregation. These cars can only be in this lot. And then the numbers indicate that one dealership can only have one manager, but that one dealership can have an infinite number of cars. The asterisk means, any number of cars. And also, one dealership can have any number of salespeople. This is not showing how you indicate how your inheritance is specified in a UML program. All right, so our card game program, which we probably scrolled past. A game consists of a deck and it consists of your current hand. I'm not really digging this example. All right, here's the UML for a more complex example. A group of cards. You have a group of cards. That's a class that contains cards. And then a deck of cards is inherited from the group of cards. And a hand is inherited from the group of cards. Notice a different symbol. And then the game consists of somebody's deck and somebody's hand. So the superclass for these guys is the group of cards. And then the deck and the hand are the subclasses which extend it so that with the deck you can shuffle your deck and you can deal a card. And in your own individual hand you could sort your cards and you can play a card. So they're adding capabilities onto the group of cards class.
So I understand that relationship, but is it really necessary to have a group of cards class? Couldn't they just inherit from the card class and be a list of cards?
Right. Why didn't we just make the deck a list of cards? And the reason why is we decided that we wanted some methods that were common to both deck and hand, which could be adding a card and displaying all your cards. And so in this case, they made a group of cards, which was a container for an individual card. And so it was an array of cards. Does that make sense? Okay. So if you're going to do inheritance, you do the arrows, the triangles. And if you're showing composition, you use the little diamonds filled in. And if you're doing aggregation, then you use the hollowed diamonds. And this particular game, you're not sharing cards between players, so there's no aggregation symbols. There's only composition symbols. And when you skip examples, you get to go through the chapter really quickly. I do recommend reading about this stuff. Just because I skip it doesn't mean it's not important. That's why you have a book. All right, we're skipping a lot, though. I'm beginning to feel guilty. But I think we've already talked about all this stuff. All right, quiz questions. In the book, what is used as a composition hierarchy example? Whatever. What word indicates that a base class is derived from another class? We know that one. Extends. What is it called when a subclass has a method with the same name? That is overriding. I like catering, though. I want some catered methods. I want somebody to bring them to me. But overriding. And then what access modifier is used in a class declaration to prevent someone from making a subclass from the existing class? Yeah, right.
Is that an actual keyword?
No, that's not an actual keyword. Although the joke way back then was that Unix was a Unix operating system based, on the Multics operating system, but whatever, that's not really strictly true. So we could declare not only our method as a final method, but we could mark the entire class as final. So I'm going to go back here and I'm going to make, not Visual Studio, I'm going to go back here to NetBeans and make monster a final class. And now that I've done that, I can't create an Oscar class that is a subclass of it. Just like we made a method that could not be overridden, now we've declared the entire class. So I'm going to fix that by removing that final keyword. Alright, we're at the end of the chapter, and I actually think that this is an adequate place to stop. Next, we're going to hit interfaces and polymorphism. And the idea of an interface is that in this language, unlike C++, the Oscar class can only inherit, it can only extend one other class. Now that class can extend another class, and that class can extend another class, and so on. But you can't say that class Grouch extends both monster and and a character, or actor or something like that. Whereas with an interface, one class can implement as many interfaces as it needs to, and an interface is a very specific form of class. And so you could say that my spaceship is a this, and that it's also a that. It implements, okay, where we're getting off on I'm going to forget about the explanation of it until that lecture. So go ahead and upload your itty bitty monster class into the Dropbox for today, and we are done for today. Any questions?
So when you talk about giving your code to another programmer, I get confused when you say that, because if you're giving them the code, do they not have access to the classes you made?
Right, so the question is when I say if you give your code to another programmer to modify or whatever, don't they have access to your code? You could be creating code in a large team, in which case, once you've written a code, you want to minimize changes to your particular class. And so you may have it checked into a version control system so that they would have to check out the monster class if they were going to make any changes to it. And if they made any changes to the monster class, it might break all the code that other people have written that uses a monster class. So in that case, it might be wiser if you need the monster class but you need to tweak it in some way, to inherit from it for your own class for your own purposes. And then if that turns out to be a good idea, you can post that back to the repository and other people could use that class. Does that make sense? So quite often, you're not supposed to be modifying some existing set of code. You're supposed to be working around it and using the API that somebody else gave you. Very good question.
Kind of like how we use like all the different APIs that people have created that we can import.
Right.
We can't modify those.
Yeah, we can't go in and modify the string class, but we could inherit from it as long as it's not a final class. Let's find out if it is. Let's go down to main, or let's make a class that is, class new string extends string. And I don't know what new string is going to do if that's any different than the other string. It's yelling at us, cannot inherit from final. So the string class has been declared as final. I wonder how many of the classes that Java gives you, like the scanner class or whatever, are all marked as final so that you can't. How rude. But anyways, as long as the class isn't marked as final, you can change it.
And now let's go in and see what
Yeah.
modified.